One of the most popular topics that we've covered at the magazine is the buildup of a 4.0 liter inline 6-cylinder Jeep engine to a 4.6 liter stroker motor. This popular configuration is built around the 4.2 liter or 258 cubic inch engine's crankshaft with a 4 liter block, and the modifications necessary to install that crankshaft in the 4 liter. I worked with Tony Hewes out of Reno, Nevada at Hewes Performance Machine. Tony's a Winston Cup engine builder, and we came up with a formula that we thought worked well for building a 4.6 liter stroker motor, and employed that with several engine builds that have been a success story. I had the opportunity yesterday to test drive a 4.6 liter stroker motor freshly built by Tony Hewes and installed in a 1998 Jeep XJ Cherokee. The truck was virtually stock, so this was really a good example of the performance potential of the 4.6 liter engine. And I'd like to share the results of that test. To start with, the Jeep had slightly oversized tires. When I say oversized, I mean around 30-inch diameter. No lift kit, no modifications to the AW4 transmission, although a new rebuilt torque converter from PDQ Automatic Transmission Parts in Sacramento was part of the build. The exhaust system was modified, a revolver header from Banks Engineering, the use of a MagnaFlow muffler, the catback system from MagnaFlow helped, a Random Technologies catalytic converter, all of which I talk about in the build list that you'll find at the article accompanying this video. Additionally, the cylinder head was ported, and in this case match ported to the revolver header to give the engine slightly more performance at the 8.7 to 1 selected compression ratio. The camshaft choice was the CompCam's 252 grind that I've used for years that Tony Hewes also agrees is one of the best possible choices for this engine. And the only modification beyond that was the use of Ford 5 liter injectors, which are rated 24 pounds, as opposed to the stock 19 pound injectors. And I list the part numbers for the injectors used. I'm fortunate in that this engine went into my friend Brent Howerton's XJ Cherokee, so I was able to drive the vehicle yesterday and actually see how it performs. At lower speeds, the engine has a torque rise similar to the 4.2 or 258 cubic inch 6-cylinder, the famous stump pulling power of an inline 6 with a longer stroke. At highway speeds, cruise above 2200 RPM, the engine pulls very strongly right up to the 4500 to 5000 RPM range. Since the gear ratios are fairly tall and the AW4 transmission has overdrive, my biggest concern was how does this engine perform at 2000 to 2200 RPM? This is a common cruise on an interstate, and at that RPM, typically the 4 liter engine falls way short of the mark. I expected that this engine would have the kind of torque rise that the 4.2 liter engine is famous for, and in fact it did. And this took my memory back all the way to the original 4 liter engine, which I had the opportunity to drive in a brand new 1987 XJ Cherokee in the Jeep Cup Rally. And the findings that I had at that time were the same as the findings that I have for our 1999 XJ Cherokee with a stock 4 liter. And that is, the engine is really lacking performance until it gets above 2600 RPM, which is totally impractical for highway cruise speeds. The use of the 4.2 liter crankshaft and the modifications that you'll see in the build list that I've provided netted an engine that is extremely smooth. And again, Hewes built the engine, so Tony's standards for blueprinting and balancing, matching pistons to cylinder walls, and by the way, he did use forged pistons, but a modern forged piston that runs closer wall clearances and does not have the noise factor on startup when cold. All of the tolerances on this engine are built to blueprint specifications, and as a result, the engine is incredibly smooth, from an idle all the way up to 5000 RPM. If you're interested in building a 4.6 liter stroker motor, a 30 thousandths oversized cleanup rebore with a 4.2 liter crankshaft and a 4 liter block, check out the list of parts that I've provided for what I consider to be an optimal build for an all-around, multi-purpose 4.6 liter engine that will get fuel efficiency, run smoothly, and outperform a 4 liter by a margin that I can only describe as V8 equivalent power.